Good afternoon, sir. Pre Pre-Submission seminar on data rate enhancement of GSM using cognitive radio webcam technology under the guidance of Dr. Ghrce Mr, sir, ex-Chief General Manager, GSM.
Please get to the main part.
Yes.
What is your contribution to this company?
Yes. Actually, for the need of the research need is that today the spectrum cost is 80% of the telecom services cost. That's why we have to cut down the spectrum cost, and for efficiently we have to use the spectrum. That will be possible by using the cognitive radio technology. GSM 900 MHz band is most suitable for the mobile communication. Therefore, researchers are trying to use it, and it is already pre-occupied by the GSM. The work suggests that the vacant channels in the GSM can be used by the cognitive radio webcam system. By 2020, GSM 900 MHz radio band will be relatively free as world will move towards the IoT and sensor network technology, which requires large bandwidth, and hence need of the cognitive radio has been established in GSM 900 band using OFDM access type. Cognitive radio means what? If license holder user, that is the primary user, if he is not using the particular frequency or band, then secondary user has authority to use that. That is the cognitive radio concept. Main objective of this thesis is to enhance the data rate of the GSM 900 MHz band by OFDM cognitive radio technology. Because now OFDM technology is available with the 2300 MHz or 2600 MHz. It is not available with the 900 MHz. That is the state of the art or the research area or research challenge. The use of CR OFDM technology employing unused channel in the same band to produce the appreciably higher bit rate than the obtainable existing technology, and that's why the cognitive radio come into picture. The potential problem with the extracting higher speed at higher frequency, it will cause the lower coverage. That's why world will move towards the 900 MHz band. I already explained that OFDM already implemented in the 2600 MHz band and 2300 MHz band, but there is no implementation in the 900 MHz band. That is our core research area. If cognitive radio is deployed along with the OFDM technology in the 900 MHz band, it will give better coverage area because the advantage is high SNR, then that means noise immunity, linear throughput, and better scalability. Thus, it suggests that available vacant channel in GSM is used by the OFDM technology by using CR technique for the enhanced throughput. This is the research gaps identified through the literature review. In 2009, by this researcher, the work reported is for Spain. He has done the survey, but he has not done for different cities. That we have achieved in our survey. In the second case, he has done for Singapore and some area of the Singapore, but not different cities or different parts of that city is not done the survey. That we have done in our case. Similarly, parallel work just now in the last month, 2017, March 2017, one paper was published in an American journal. It is a parallel with our work. The high speed of our data transmission in GSM network based on the cognitive radio. This will suggest they are giving the only idea, but we are actually implementing in by using the ATOL tool, which was used by the internationally by telecom companies. The objective of the research work, the main objective of the research work is design CR OFDM such a way that enhance the data rate of the GSM 900 MHz band. There are different steps for achieving this research. First step is first study the vacant channels. in the GSM band for cognitive radio implementation, because we already told that cognitive radio will work when primary user is not using, secondary user can use that. Then the second step is study the effective throughput or spectral efficiency provided by GSM. Third is the spectral efficiency provided by other technologies such as CDMA, OFDM 2600 MHz. Then design the parameters of cognitive radio OFDM in GSM band and spectral efficiency. And last step is measurement of data speed provided by the GSM and OFDM at same location for depending the research work. The measurement strategy is first we have to use the drive test equipment. We have done which will consist of laptop along with testing software such as Agilent or Nemo for data acquisition, car mounted GPS, USB splitter and dongle from different companies. And we have to use the ATOL planning tool, that is a well-known, internationally known radio planning tool to validate the result or verify the result. Then live collection of data for different cities, Patna, Kolkata, Pune, Chakan, etc. The live collection of data we have done. Analysis tool software also we have to use it. Now, first step we have to find out the vacant band, and for that purpose we have done the live drive test. And for the live drive test, the main purpose is to find out the vacant channel in the GSM band. And through the drive test at Bhopal, Patna, Ranchi and Dirbar, we have collected a lot of data and we have to find out the vacant band. And one paper was also published in the IEEE Explorer. And these are the 50% vacant, 60% vacant, 90% vacant channels are there, and percentage of spectrum occupancy is also displayed. Then we have find out the spectrum efficiency of GSM 900 and other technologies such as CDMA, OFDM at 2600 MHz. For different experimentation we have done, and we got the result for GSM AH spectral efficiency we got around 1.2 bits per hertz. And similarly for CDMA video we got 1.4 bits per hertz, that is shown in the graph. And again one paper was published on this results in the IEEE Explorer. After that we have done the comparative comparison of spectral efficiency with respect to OFDM 2600 MHz, CDMA, and another paper we have published in Elsewhere journal Procedia. Now, cognitive radio design parameters for OFDM 900 MHz, because OFDM is now available at 2300 MHz and 2600 MHz. And for that purpose, you have to consider three conditions. One is the transmitter, second is the receiver, and in between that is the media, objects in the environment. And for that purpose, you have to consider delay spread. Delay spread is dependent on the exponential power delay profile, which is measured under different environmental conditions. That can be directly find out from the ITU channel model A and B under different environmental conditions. For the in working environment of GSM, neither it is possible to measure such parameters which will cause interference to working connections, nor any drive test tool provide these parameters. Hence, in absence of power delay profile, we consider a drop of 30 dBm additional path loss from peak value, and then we have to calculate the other parameters. Cognitive radio proposes to deploy OFDM in GSM band and provide service through several base stations around single cognitive radio receivers. And for that purpose, we have to consider OFDM design parameters, which will consist of guard time, cyclic repeats, symbol time, sub-carrier bandwidth. And at that, when you design the parameter, we also consider the different issues such as ISI, intersymbol interference, ICI, intercarrier interference. All these parameters you have to consider. And that for that purpose, we have to assume some parameters such as assuming maximum coverage of GSM, we are considered as a 5 km for the direct path, and reflected difference path we are taken as a 2 km. Maximum excess delay spread we have calculated by the formula speed equal to distance upon time, that will calculate 6.6 microsecond. And coherence bandwidth is calculated 1 divided by 5 tau m. Tau m is the excess delay, and we got the 33 kilohertz coherence bandwidth. What is the requirement to avoid the ISI? Is the subcarrier bandwidth must be less than the coherence bandwidth. The maximum Doppler frequency shift is given by the formula V by lambda. We have calculated that will give you 33.3 Hz. Doppler spread, when it is less than the subcarrier bandwidth, there is a no availability of the ICI, intercarrier interference. Now already we know that 900 MHz band, there is a carrier bandwidth of the 900 MHz band is 200 kHz, and we have to divide that 200 kHz into subcarriers, and for that purpose we have used the different formulas. Then Fd equal to C divided by V plus C into F0 minus F0. By using these formulas we have to calculate, and actually 200 kHz is divided by considering the 16 2 raised to n power, that will give you 10.93 kHz subcarrier spacing, and by using that subcarrier spacing we have to calculate other parameters such as symbol length and inverse of the subcarrier spacing. That Tu is given as 1 by delta F. Tu is nothing but a useful time, and Ts is the symbol time, Tu plus Tc. For all practical purpose, guard time you have to consider as 1/8, that is a standardizing the things. Now for webcam design consideration, you have to consider the BR measurements also, GSM throughput also. Now you have to consider 3 environment types. One is the urban, second is the rural nomadic, and third is the rural vehicular. For urban, we are considering gamma equal to 4.5, that is loss, and D equal to 3 km. Traffic speed here, because it is a urban, that's why normal speed, that is 18 km per hour. For rural nomadic, gamma considered 3 and speed considered as 5 km per hour, and for rural vehicular speed will be somewhat increased because there is no congestion there in the rural side. 50 km per hour we have considered, and according to ITU recommendation we have considered the different channel type and find out the different optimal CP length. And loss will be calculated by using this formula. ICI power probability we have find out. Then coherence time, we have calculated channel coherence time. For the here mainly issue we have to resolve is tau Ts must be greater than tau max, and Ts must be less than the T coherence time. Thus we have to find out the spectral efficiency by using this formula, eta equal to n mod divided by n into log to the base 2 m divided by 2, where n mod is nothing but number of useful subcarriers for the data and number of subcarriers. And from applying this concept, OFDM designing part, then we got this peak error rate at different constellation. At m equal to 4, that is the QPSK, m equal to 16, m equal to 64, finding out the different SNR values. Then we got this table for.
Let me see that back.
Then we have to find out different modulation types, 16 comm, QPSK and 64 comm, and finding out the different values of N, C, BT. This is the actual webcam design parameter. I already told you that 200 kHz is the bandwidth because GSM 900 MHz has 200 kHz bandwidth. That is divided 25 out of that 25 kHz is used for the guard band and other purpose. And remaining 175 kHz divided by the 16, that will give 10.393, and remaining 12, 2 is for the subcarrier, 1 is the guard band, 2 and 1 is the DC subcarrier. Like that, 12 plus 2, that is 16. In this way, this designing has been done. Now we have whatever design we have done, that we have to validate, and that validation is done by the ATOL tool, which will be used by internationally accepted by the different telecom companies. and by using that at-all planning tool, we got the results in OFDM in 900 megahertz band. That at-all tool is useful for all this 450, 800, 900 at any frequency range that will be useful. And for that purpose, whatever the live data we have collected at Chakan Pune, that same results. This is the actually at-all tool results that will give this data rate. 4400 kbps and minus 7.
The data. So what is the units down?
kbps, 4400 kbps.
So this x-axis, what is the
dBm, minus 70 dBm.
So signal strength is reducing with the
Yeah.
okay, fine.
And similarly, when we have to implement into the waveform into 900 megahertz, then data rate increases. It is a 38,000. When it is in the 2300 megahertz, data rate is less. But when it implemented into the 900 megahertz, data rate will increase. And because now GSM, everybody is moving towards the data. Now voice is also through the data. That's why GSM 900 band becomes free, and that is the research point. Now we have to implement that, and we have to use this technology. And same direction paper, just it was produced in the American journal. That copy is available. This is the GSM 900, OFDM 900. When OFDM implemented 900, this much data speed we will get. Only thing is that this research, if ITU accepts, then transmitter are produced, then that will give.
Okay, done?
Yes.
So
Publications are for elsewhere.
can you explain this 7.8 to the
Yes.
yeah. So why is this figure not symmetrical?
No, according to when you are moving from the base station, the signal strength goes on.
So what are the reasons that this is not a very symmetric figure?
According to environmental condition and as when mobile will move away from the BTS, the data rate will go down.
It will fall off, but these green areas which are there, so one side is like this. So is it see, you know about lobe patterns and all that?
Yeah.
So Chaka.
At Chakan there are different area, means it is somewhere industrial area and some are towns are there. It is different area, not symmetrical area is there.
Is there any hill?
Hilly area is there. Hills.
In one side industry.
Industry and one side field.
Field side is the right side. The protected zone.
You should be able to say this.
Hilly area and
वो चट्टान का पिक्चर सर ये एक्चुअली क्या है दूसरा जो कॉपी जगह हुआ
If you overlay topographic map on this, you overlay topographic map. Okay. Then from that you can make out some side there may be some obstructions, something like that. Okay. Right. Right. Okay. So,
Thank you. QoS.
Next.